Continental drift is the idea that the continents on Earth have been slowly moving away from each other over millions of years. Think of the continents as giant puzzle pieces that were once all connected in a single supercontinent called Pangaea. Over a very long time, these pieces broke apart and have been drifting to their current locations. The Earth's outermost layer, called the lithosphere, is broken into large pieces called tectonic plates. These plates include both the continents and the ocean floor. These plates sit on a layer called the asthenosphere, which is part of the Earth's mantle. The asthenosphere is not a liquid ocean of magma. It's actually solid, but it's incredibly hot and under immense pressure, making it plastic or ductile. This means it can flow very, very slowly, like a thick, gooey substance over millions of years. The immense heat from the Earth's core causes this solid rock in the asthenosphere to move in a cycle called convection. This slow churning motion is what drags the tectonic plates along with it, causing them to move, collide, and separate.
I'm the snow and ice of Antarctic. I carry in me the secrets of many ages. I may look young and fresh, but I am millions of years old. If you study me, you'll get to know more about this planet Earth. If I melt and become water, then your cities will drown. You must not allow me to melt.
Hi.
Hello.
For so many years, we have ruled the planet.
Yes, you are right.
We were the unchallenged rulers of the land.
But today we are not here.
Because we are extinct.
You say you are more intelligent than us? Are you?
Why do you ask?
Because your actions don't present you as intelligent.
You are paving the way for your own extinction. You must act intelligently.
Earth is your only home. You must keep the earth livable.
Intelligent is one who protects his home
And doesn't destroy it.
Yes, you all are right. I must reform my ways and work in sync with nature and not against it.
We do not want your species to become extinct like ours.
I understand that the alarm bells are ringing. If we don't act now, it may be too late. Thanks for the advice.
What climate change? You're always talking about the climate change. I don't see any change. Why are you so worried about the future? Cheer up, have fun.
How can you be so ignorant? The climate change is a reality. The polar ice is melting. The planet is getting warm. We have to do something. It is urgent.
Welcome, curious minds. Today we're embarking on quite a journey, a deep dive into one of the most extreme yet profoundly important places on our planet. We're heading to Antarctica.
That's right, a continent that really holds vital keys to understanding our Earth's past, its present, and maybe even its future.
Yeah, and incredible insights for this deep dive from a traveler's first-hand account. It details a journey aboard the Russian research vessel, the academic Shikolsky, heading straight for, well, the coldest, driest, and windiest continent on Earth.
Quite the destination.
Exactly. So our mission today is to sort of extract the most impactful nuggets of this material. We want to help you grasp why this icy landscape is so much more than just, a frozen wasteland.
Absolutely. And it's really not just a travelogue, is it? It's a profound reflection on geological time, human impact, subtle but powerful, and the delicate balance of our whole global ecosystem.
Yeah.
What's really fascinating is how a personal journey unfolds into this deeper understanding of, well, universal scientific truths.
Okay, so let's unpack this a bit. Imagine starting a trip. Get this. 13.09 degrees north of the equator in Madras, India.
Right. Quite a starting point.
And then traveling for over 100 hours.
Wow.
Crossing 6 checkpoints, 3 bodies of water, and traversing at least as many distinct ecological zones. Going from tropical all the way to polar.
An incredible transition.
And doing it all by car, airplane, and ship. That's the kind of scale we're talking about just to get to Antarctica, based on our sources.
It really puts the isolation into perspective, doesn't it?
And the author describes that first emotion, finally setting foot on Antarctica's massive white landscape, that uninterrupted blue horizon, first feeling relief.
I can imagine, after all that travel.
Definitely. But then, almost immediately, this profound wonder kicks in. Wonder at its sheer immensity, its stark isolation. But here's where it gets really interesting and what sparked a big aha moment for the traveler. Wondering how India and Antarctica could ever have been part of the same landmass.
And that initial sort of visceral connection, that wonder, that's precisely what primes you for the deep dive into Earth's ancient history.
How so?
Well, it makes that abstract idea of drift suddenly feel incredibly real. It connects a personal feeling, that moment of awe, to billions of years of planetary evolution. It just challenges our whole perception of land masses as fixed things.
So it's not just a feeling, it's backed by science. Our sources confirm that, 650 million years ago, a giant supercontinent, Gondwana, did indeed exist.
That's right. Centered roughly around present-day Antarctica.
And as you might guess, things were vastly different back then.
Oh, completely different. What's truly astonishing isn't just that these huge landmasses moved, but how their movement fundamentally engineered our global systems.
Right.
For 500 million years, Gondwana, it had a huge variety of flora and fauna. This was long before humans arrived on the scene, of course, and the climate was much, much warmer than Antarctica is today.
500 million years.
A vast time scale.
But then, around the time the dinosaurs were wiped out, give or take, and the age of mammals really got underway, this massive landmass was forced to separate.
Yep, poured into the continents we basically recognize today.
It's just mind-boggling when you think about the sheer scale of change. What can happen over millions of years.
And this separation wasn't just, continents drifting apart. It triggered incredible geological events that still define our world.
Like what?
Well, think of India pushing northwards, just jamming it with immense force. That buckled the Earth's crust and formed the Himalayas.
Wow. The highest mountains on Earth.
Exactly. Or South America, drifting away from Antarctica, moving off to join North America. That opened up the Drake Passage between them.
Okay.
And that newly opened passage allowed a cold circumpolar current to basically circling Antarctica. This current effectively isolates the continent, keeping it frigid, desolate, and stuck at the bottom of the world.
So understanding those processes really helps us grasp the huge dynamic forces still shaping our planet today.
Precisely. It's an ongoing story.
Now, for someone used to constant sunshine, like the author, the sources say spending 2 weeks in a place that stores 90%, 90, of the Earth's total ice volume. Well, it's a truly chilling prospect, literally and figuratively.
Absolutely. 90% is staggering.
It's described as an environment so vast, so undifferentiated, like walking into a giant pong ball. It strips away all your familiar markers for space and time. No trees, no billboards, no buildings.
You lose all earthly sense of perspective.
Yeah, just this unending white expanse and horizon. It forces you to confront immense scale and isolation.
And the visual scale there is just incredible. It ranges from the microscopic mates, believe it or not, all the way up to the mighty blue whales, icebergs as big as entire countries.
As big as countries?
Yeah, the largest one recorded, our sources note, was actually the size of Belgium.
That's hard to even imagine.
It is. And then you have the days just going on in that surreal 24-hour austral summer light. And this pervasive, mostly, yeah. It's interrupted only by the occasional avalanche or maybe a calving ice sheet breaking off. It really consecrates the place because it's this profound quiet. And this kind of immersion, being in that environment, it really forces you to place yourself in the context of Earth's geological history and maybe realize how fleeting our own is within it.
That profound isolation, that untouched grandeur, it is humbling. But as you say, that immersion also brings pretty stark realization about our own brief yet incredibly powerful impact on the planet.
Yeah.
Because when we start considering humanity's footprint, the sources suggest, well, the prognosis for the future isn't quite as serene as the landscape might appear.
No, it isn't.
Our human civilizations, they've been around for, a paltry 12,000 years?
Barely a few seconds on the geological clock, really.
Exactly. Yet, in that incredibly short time, we've managed to create quite a ruckus, haven't we? Etching our dominance over nature with our villages, towns, cities, megacities, fundamentally reshaping landscapes.
And the rapid increase in human populations has led to this intensified competition, not just among ourselves, but with other species for limited resources.
Right.
And critically, the unmitigated burning of fossil fuels over the last couple of centuries has created this blanket of carbon around the world. It's slowly but surely increasing the average global temperature.
So this raises a really important question then. How does Antarctica, this continent that seems so remote and untouched, fit into this urgent global debate about climate change?
That's the crucial link.
It is a crucial element, and not just because it's the only element that's never sustained a permanent human population, right? So it remains relatively pristine, a kind of benchmark.
True, that's part of it.
But maybe more importantly, because it holds in its ice cores these incredible half-million-year-old carbon records. They're meticulously trapped, layer by layer, within the ice itself.
That's it, exactly. The ice is the archive. If we want to study the Earth's past climate, understand the present, and project into the future, the sources are clear. Antarctica is the place to go.
So this data is vital.
Absolutely vital for understanding those critical questions like, will the West Antarctic ice sheet melt entirely? What would that do to global sea levels?
Huge implications.
Massive. And extreme ocean current, which is so important for global climate regulation, be disrupted. The ice provides this undeniable physical evidence of our planet's trajectory.
Okay, so given the scientific urgency, what does it all mean for the future, particularly, for the next generation who will inherit this situation?
Well, that's where education has become key.
Our sources actually highlight a specific program doing interesting work here. It's called Students on Ice.
Ah, yes, Students on Ice.
And its aim is to address exactly this, taking high school students literally to the ends of the world, to the Arctic and Antarctic.
It's a fascinating initiative headed by Canadian Jeff Green. 6 years, according to our source material. Green apparently got tired of carting celebrities and retired rich curiosity seekers who could maybe only give back in a limited way. With Students on Ice, the focus shifted. He offers the future generation of policymakers, scientists, leaders, this changing experience.
At an age when they're really ready to absorb, learn, and most importantly, act.
Precisely, when they're forming their worldview.
And the reason the program seems to be so successful, so profound, is pretty straightforward. It's basically impossible to go anywhere near the South Pole and not be deeply affected by it.
You'd be changed by it.
Right. It's easy maybe to be a bit blasé about polar ice caps melting when you're sitting comfortably at home reading about it.
We feel distant.
But when you can visibly see glaciers retreating with your own eyes, when you witness ice shelves collapsing, you begin to realize that the threat of global warming is very, very real. And
moves from abstract concept to lived reality.
Exactly. Now, to really appreciate the fragility of this globally significant ecosystem, our sources suggest we need to zoom in, way in.
Down to the microscopic level?
Yeah, to the smallest elements that actually hold the whole thing together. Take, for instance, the microscopic phytoplankton.
The grasses of the sea.
That's it. They nourish and sustain the entire Southern Ocean's food chain.
And these single-celled plants, they're not just foundational to that marine food web, which is critical in itself. Their photosynthetic activity plays this massive, often overlooked role in the global carbon cycle.
How so?
Well, it's the sun's energy to assimilate carbon dioxide and synthesize organic compounds. That's photosynthesis. They're drawing down CO2 from the atmosphere into the ocean.
Right.
And scientists warn that a further depletion in the ozone layer, which allows more harmful UV radiation through the eopan, will directly affect the activities of phytoplankton. It damages them.
Right.
And will cascade through the lives of all the marine animals and birds in the region that depend on them. And critically, it impacts the global carbon cycle itself. Less phytoplankton means less CO2 uptake.
So it highlights how these seemingly small changes right down at the bottom of the food chain can cascade into really significant scale repercussions.
Absolutely. It's a perfect example of interconnectedness.
And this sensitivity of Antarctica's ecosystem, shown through the phytoplankton story, it offers a really compelling scientific lesson, doesn't it?
It does.
That understanding and protecting these foundational, maybe seemingly small elements can have these disproportionate effects on the health of the entire planet.
It's the parable of the phytoplankton, as the source puts it.
Yeah.
Take care of the small things.
And the big things will fall into place, yeah. Now, the deep dive in our source material concludes with this really powerful epiphany from the journey itself.
Oh.
Just short of the Antarctic Circle, the ship the academic Shikolsky, it wedged itself like a white stretch of ice. It couldn't go further.
Okay.
So all 52 people aboard were instructed to climb down the gangplank and actually walk on the ocean.
Walk on the ocean. On the sea ice.
Exactly. There they were, walking on this stark whiteness that just seemed to spread out forever.
Must have been incredible.
Underneath their feet was about a meter-thick pack of, and underneath that, 180 meters of living, breathing salt water.
Wow.
And nearby, crab-eater seals were just stretching and sunning themselves on the ice floes, like it was just another day for them.
And for the humans?
The author describes it as nothing short of a revelation.
A revelation.
How? Just this tangible experience that everything does indeed connect.
Ah, yes. If we tie that back to everything we've discussed, the geology, the climate, the biology, it just underscores that profound interconnectedness of all life and all the geological processes on our planet.
A scientific truth felt on a deeply personal level.
Precisely. The power of such an experience.
So after crossing those 9 time zones, 6 checkpoints, 3 bodies of water, and goodness knows how many ecological zones, the author was left pondering just the incredible beauty of balance and play on our planet.
And this whole deep dive into Antarctica, it really shows us why it's such a crucial place to go. If you want to understand the Earth's present, its past, and its future, it unveils the immense forces, that shaped our continents over millions of years. It reveals the delicate balance of ecosystems, like with the phytoplankton. And, maybe most urgently, the profound impact of human activity, all seen against that vast geological.
It definitely leaves us with a compelling, maybe even unsettling thought to end on.
Which is?
What if Antarctica were to become the warm place that it once used to be millions of years ago?
A profound shift.
Will humanity even be around to witness such a transformation? Or would we have gone the way of the dinosaurs, the mammoths, the woolly rhinos?
Give us a definitive answer on that,
yeah.
actually.
But maybe after exploring the idealism and dedication of programs like Students on Ice, that next generation working to save the world, perhaps there's significant hope.
There's always hope in action and understanding.
As our sources eloquently put it, a lot can happen in a million years, but what a difference a day makes. And concerted action can make a difference.
Indeed.
Well, we hope this deep dive has given you a newfound appreciation for Antarctica and for the really critical insights it offers for our shared future.
Keep exploring. Keep questioning.
Global warming and melting ice. 80% of the world freshwater reserve is locked in Antarctica as ice. If all the ice melts, then sea level will rise by 200 feet, submerging the great coastal cities. World population is about 7.8 billion. About 3 billion live in those cities. Where will all those people go? To understand the impact, I made a city and created a sea. You can see the sea level. The city has a comfortable coastline. Now I am adding ice. Global warming is melting the ice, causing sea level to rise. See the melting ice. The city is getting flooded. More ice. More melting, more water. The city is on the verge of collapse. The city has collapsed. There is no city but only seawater. That's the impact of global warming. That's the impact of melting ice. Thank you. Hi, I have written on slips of paper the different ages according to the geological time scale of our planet Earth. The ages can be divided into two parts: Precambrian and Phanerozoic. And we are talking about 1,000,000,000 years. So what I'm going to do is that I'm going to place the first age, that is Hadean, inside this plastic container, and then I'm going to place ice blocks over that slip. This experiment is to show you how the different ice layers of Antarctica preserve the history of our planet. Now, the second age, that is Archean. The first age, Hadean, was marked by intense volcanic activity, and the second age, Archean, showed the first evidence of life. This is the third age, Proterozoic, and this showed the increased level of oxygen in the atmosphere. So all these things, all these records, all this data is getting preserved in these successive layers of ice that I am creating. So that is exactly how the ice of Antarctica has preserved billions of years of our planet's history. The next age is Paleozoic, and this is marked by diversification of life. Now, that is also covered by ice. So we have another layer of ice, and after that the age will be Mesozoic. And Mesozoic is the age when the dinosaurs ruled the planet. So it marked the rise and the fall of the dinosaurs. Now all the data regarding the dinosaurs is getting preserved in this layer of ice. And the last phase, that is our present phase, the phase in which we are, is Cenozoic. And this is characterized by the diversification of mammals. So as you see, there are many layers inside this plastic container. The same layers are there in reality in the continent of Antarctica. And if we dig out the ice, then we'll find all the recorded data. And that is why it is written in the lesson, The Journey to the End of the Earth. The name of the lesson is Journey to the End of the Earth by Tishani Doshi from VISTAS class 12. It's written there that the ice of Antarctica holds 500,000-year-old carbon records trapped in its layers of ice. If we want to study and examine the Earth's past, present, and future, Antarctica is the place to go. Thank you.